I know last time.
Greetings and welcome, friends. We've been talking about the distance from a point to a line, specifically a line in the normal form, because it actually ends up being quite easy. So distance is what we've been talking about. We're on page 475, I'll call it. And here's question 11. It says find the distance between the point with the given coordinates and the line with the given equation. So here I've got the following. Let's see. I'm going to define my A, B, C's, blah, blah, blah. So cap A is 3, cap B is -4, cap C is 15, and I might want to point out that it's positive. And the value of my point, x1, y1, would be the 2 and the 0. So the distance, all right, from this point to that line, I could actually go through the process of converting this to normal form and then merely plugging in 2 and 0 for the x and y. And whatever that equation equals would be the distance. Or I can kind of do it all at once, which is the formula that we'd been given from the book. So 3 times 2 plus -4 times y1 is 0. I believe it's plus c if I'm not mistaken. All over the square root in question regarding the sign of the square root. It's technically the opposite of the c if I recall. Over a squared, so that's 3 squared plus, let's see, better plus sign right there, b squared like so. So I end up getting 6 minus 4 plus 15 all over the negative square root question.
4 times 0.
Ah! So it begins. Fixing my mistakes. Here we go. And I know this is negative, but we're going to end up taking the positive in a second anyway. 9 plus 16. This is going to be square root of 25. You might have even realized 3, 4, 5 right triangle sort of thing. 21 over the negative square root of 25, which is 5, I might point out. So negative 21 fifths. And yeah, we'll take the positive of that since we're talking about a distance.
So even if it is negative, you're always going to change the sign to be positive anyway?
When I'm dealing with a distance. Now, if I was just going to convert this to normal form, I would have kept the negative, because based on the value of phi and p, that negative would be significant. But since I'm referring to a distance, I'll just positivize it there. So that would be the distance from that point to that line. Not that bad. So let's take a look at one more example. It says find the distance between the parallel lines with the given equations. Now, what you do here, you just have to pick a point on one of them. Whether I find the distance from the first to the second or the second to the first, theoretically that should be the same. And what I would point out about this first equation is, hey, that's in slope-intercept form, so I know that the point 0, 6 is a point within my line, x1, y1. Although any point on either of the lines would have worked.
Wait, why isn't it 1?
Because this is the y-intercept. Right,
Oh,
so
okay.
6, so yeah. So plus y, and I'll subtract 4 from both sides just to get this into our standard form here. And I'll get a is equal to 3, b is equal to 1, c is equal to -4. And let's find the distance. 3 times 0 plus 1 times 6, there we are, plus -4. All over the positive square root this time, because it's the opposite of that, of 0 squared, nope, 3 squared, sorry, it's a and b squared, plus 1 squared, so equals 3 times 0, not going to fool me twice, shame on me if that's the case, apparently, according to cliches or riddles. And if it rhymes, it's got to be true, from what I understand about things. So let's see, I get 6 minus 4 is 2 over the square root of 10. Oh, we would never leave it that way. Multiply by rad 10 over rad 10. Yeah. and I would get distance is equal to 2 square roots of 10 over 10, like so.
Simplify.
Oh, wow, I didn't even check. That's mistake number 2, but that's fine. Square root of 10 over 5. There we go. There we go, right? Because the 10 and the 2 partially cancel, like so. So anyways, thanks for watching, Internet friends. Have a great day. Bye-bye.